Okay. For just take this one as letter A, B, C, D, E, and then F. Okay, so for letter A, explain how an object can have positive acceleration and positive velocity. Well, should be moving. Object moves in positive direction with increasing speed. So that means that the magnitude of velocity increases also. That's what happens there. You have a positive acceleration and negative velocity. So negative velocity. So in this case, object moves in negative direction. So it could be south or east or west. Okay. So negative direction. And if you have noticed, uh, even for the position time graph and the velocity time graph, the magnitude decreases, so it slows down. Okay. Then you can see in that particular case that then moves in positive direction. Your answer could be different, but in essence, the thought should be the same as this one. So, negative velocity, positive acceleration. So it moves in the negative direction, but the magnitude of that velocity decreases until such times that it went back and moves in the positive direction with an increasing velocity afterwards. Okay, but you can just disregard the last phrase here. That's still okay. That means that at least in that particular case, you see that if you have a positive acceleration and negative velocity, both have different directions, the object slows down. Because actually, this is the same thing with letter C. Negative acceleration but positive velocity. So it only says that the object, if you can observe with that one, moves. So the object moves in positive direction, but slows down. Okay, maybe you can just stop there, or you can extend it, then moves in the uh, negative direction. Okay, then then goes in the negative direction. Because later on we will try to generalize these things. They are answers. So if you can see here, letter D is negative acceleration and negative velocity. So if you can observe where their position time graph as well as the velocity time graph, the object moves in negative direction. It moves in the negative direction, but moves in the negative and faster. Okay. So the magnitude increases. It's just that it's moving in the negative direction. So it moves faster. If you can see the magnitude again, don't take the values of your negative velocity as a lesser number. Again, the negative sign in your velocity time graph only tells you that it's moving in that direction. But essentially, its magnitude or the size or the magnitude of that velocity is also bigger as you move to the left, or again, if it's becoming more and more negative, because the negative sign there only indicates its direction. So essentially, it moves in the negative direction, but it moves faster because if you can see the value of that increases, okay? And letter E, you have here zero acceleration and negative velocity. So zero acceleration and negative velocity. Well, zero acceleration means that it's just moving with a constant velocity. Object moves in the negative direction with same speed. Remember that when I say speed, it's just the magnitude of the velocity. So if you can see there, that is just a straight line graph in the velocity time graph. Okay. And letter F, negative acceleration and zero velocity. So it just tells you that the object is initially at rest. Then speeds up in the negative direction. For all of these questions here, you can actually deduce this one into two. Like, you can think of velocity and acceleration having the same sign. So just like in the case of letter A and letter D, right? And in a case wherein the acceleration and velocity have different directions, okay? So in that particular case, you can summarize your results here as, well, looking at their directions. So you can say that when the acceleration and velocity point in the same direction. So again, that's the yellow case there, the yellow highlighters that I point out. So the acceleration and velocity are in the same direction in that particular case. The object will speed up in that direction. Okay, so that means that you should expect that the magnitude of your velocity increases, but for the direction part, well, it depends on the direction of your velocity. Again, that is the first case. You have the same direction of your velocity and the acceleration. The other case is that when A and V point in different directions, okay, you're gonna expect that the object will slow down. Okay, so again, slow down means that it would decrease, the magnitude of its velocity decreases. Okay, and actually, if you're gonna ask why is it that particular case, well, the explanation for this one would be answered when we talk about dynamics. Okay. So do you have any question with this part here?
Yes, sir. For the question B and C, if I didn't write the then move in positive direction, is that okay?
Yeah, is that, yeah, that's okay.
And for the you write the positive direction and the negative direction. Can I just write the west or east?
Yeah, that's okay.
Okay,
Yeah.
that's
Because you might, again, we have two directions that we use as positive. It could be north or east, and then so that I just generalized that one. So whichever is the positive direction that we use. Okay. Any other questions, or does this make sense?
For
Like,
B and C, how do
yeah.
we know that it turns around?
Uh, well, if you can see there, as long as there is a acceleration that opposes the initial motion of the object, uh, if that particular acceleration exists, moreover, you can expect that it should always moves in the opposite direction, now in the direction of your acceleration. The explanation for that one is that that happens if you're moving east. What makes you slow down? Well, actually, the one that will make you slow down is that if there's an application of, you call that force, like if someone is pushing you to the different direction, and actually that is the direction of the acceleration. The direction of the acceleration is the direction of the force that is being applied to the object. So if that is constantly being applied at a later time, it would be expected that you will be moving wherever is the direction of the acceleration because of that application of the net force. But then again, for now, we're just describing motion. So we're not really into explaining into things yet. Okay. But if you have seen in our different velocity time graphs and the acceleration part there would be a time because let's say it started with negative velocity. If you can see there, it slows down until it reaches zero. But if that acceleration still persists, that particular zero will move up, right? So that means that it goes in the positive direction already. So when that happens, it is now positive, but it's increasing in magnitude. So same thing with negative acceleration and positive velocity. So positive velocity tells you that the object is moving in the positive direction. But since of the negative acceleration in this particular case denotes that it is decreasing in magnitude until, if you can see in the graph, it reaches zero. So in that particular case, it stops. But since there persists a negative acceleration, in that particular case, you're thinking of, again, just this is moving ahead. You have a net force still being acting on that object. It now moves in the opposite direction with increasing magnitude. Does that make sense though?
Yes.
Okay, great. Okay. Yeah, later on, again, as I mentioned to you, the you don't need to again, once we're done with kinematics, I always tell my students that anything that you learn in kinematics is somehow related to dynamics later on. Okay? Because all of these things now make sense if we incorporate forces, like forces, or well, we generally forces are just an external something that affects the motion of objects. Any other questions? Okay, if there's none, we can proceed with the next question here. Example number 4. So example number 4, a car is traveling south at 16 meters per second. If the car accelerates at a rate of 0.50 meters per second squared south for 7 seconds, what is the final velocity? So we're given here this velocity, this acceleration, and the time, right? So it's moving south. So therefore, in our case, we use the convention that north is positive, south is negative. So therefore, when I try to write my given here, again, just for the calculation, so that the algebra is much simpler, because it doesn't make sense, s minus s. So instead, we try to interpret using our coordinate system that south is negative. So a car is traveling south. What do you think would be this velocity? Well, in this case, it's asked for the final velocity. So therefore, we can think of that one as the initial velocity. 16 meters per second south. But then again, for computation purposes, it's much easier if we're going to replace south of negative quantity. So south means negative in our coordinate system that we use. And then the acceleration is also in the same direction, 0.50 meters per second squared. So A would be 0.50 meters per second squared. It's again south, but in our computation, it's much better to use the negative value of that, meters per second squared. Again, just replacing my south direction with the negative sign. Okay, so as I mentioned last time, you can actually change your coordinate system, but might as well just stick to the things that you are quite familiar of. The Cartesian coordinate system is quite common, or at least you've learned that one since maybe in your lower years, so might as well stick to that one. So those are two givens, and the time, we're given the time also. Time is 7 seconds, or the delta t. Okay, 7 seconds. And we want to solve for the final velocities. We're solving for VF. Okay. So for our solution, again, we're given initial and final velocities, the acceleration, and the time. So therefore, this should be the equation that we need to use. Equation for acceleration, delta t. Okay, so everyone is given except for VF. So again, as I mentioned earlier, if you're quite comfortable manipulating the equation first, you can do that. But if not, you can just substitute and then solve. You can also substitute and then solve. Just make sure that you are using the correct signs here. Okay, so that you'll get the correct sign also of your final answer. And the sign of the final answer, remember, will give you, let's say if you're solving for the velocity, gives you the direction. And remember that the question is, we need to find the final velocity. So that means that we need to find both the magnitude of that velocity and its direction. So it's very important to use correct signs also. So I should emphasize that my acceleration is negative, so negative 0.50. VF is the unknown, so I don't know that one, so leave it as is. And then the initial velocity is negative 16. So this is where the consistency of your signs is very important, because remember, VF minus positive 16 is different with VF minus the negative of 16. So I'm just substituting everything up. Delta T is 7 seconds. Okay. So I'm just gonna simplify this equation here. Negative 0.5 is equal to VF negative negative, or the opposite of negative 16 is positive 16, all over 7. So to solve this one out, what I'm gonna do is gonna get rid first of the denominator. To do that, I'll multiply both sides by 7. So that would give me negative 3.5. Negative 3.5 is equal to VF plus 16. And solving for VF, I need to subtract both sides by 16. And this should give me negative 19.5 meters per second as my VF. And in just one sig figs, because again, the significant figures is just based on whatever the significant digits of the given quantities, VF will give me negative 20 meters per second, or the final answer, negative sign, tells me that it is in the south direction.